Alright, so let's go through this example 14. So example 14, I believe there's some error lah. So they say if tangent x is equal to 2, where x is more than pi over 2. So pi over 2 is as good as saying 90 degree. Then after that, pi is less than 180, right? I mean, x is less than 180. They ask us to find the value of cosine x. Okay, what's the problem with the question is, because for this, right, for example, let's just say we are at more than 90 and less than 180, we are actually at the S territory. So meaning we are at the sine territory. So if you say tangent is positive, it doesn't really make sense. So I believe it's just a minor thing. It's a minor, I think, error. So I think there's a negative associated to the 2. Okay. So now I put a negative 2. So let's just say tangent x is negative 2. So how do we actually find what is your cosine x? Right? Okay, very simple. So first thing, we always draw the triangle, right angle triangle like that. So what is it? So for example like this. Then after that, okay, negative 2 is as good as saying negative 2 over 1. So it's right? Opposite over adjacent. So I just put the 2 first, I put the 1. So of course I must put a negative to some place, right? So I always put the negative to this, because apparently, right, you look at this length, it's towards the left hand side. So if it's towards the left hand side, must always be here. Then why don't I put at the 2? Because apparently 2 is upwards, so upwards is always positive. Okay, so with this, maybe we can actually solve for cosine already, right? So cosine x is equal to j over hypo. So of course, you determine the hypo first. So use the Pythagoras theorem, right? 2 square 4, right? 1 negative 1 bracket square is 1. So means your hypo is about square root 5. So the adjacent is minus 1, hypo is square root 5. So means your cosine x will be negative 1 over square root 5. So of course you can actually rationalize it, but of course I don't think it's necessary in this particular case.